Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, Electrochemistry. Last class I have finished solution. Now I am going to start Electrochemistry, third chapter. Electrochemistry is the study of production of electricity from energy released during a spontaneous chemical reaction and the use of electrical energy to bring about non-spontaneous chemical transformation. The subject is of importance both for theoretical and practical consideration. A large number of metals, sodium hydroxide, chlorine, fluorine, and many other elements are produced by electrochemical methods. Batteries and fuel cells convert chemical energy into electrical energy and are used on a large scale in various instruments and devices. The reaction carried out electrochemically can be energy efficient and less polluting. Therefore, a study of electrochemistry is important for creating new technologies that are eco-friendly. The transformation of sensory signals through cells to brain and vice versa, and communication between cells are known to have electrochemical origin. Electrochemistry is therefore a very vast and interdisciplinary subject. Here you will study all these things. Electrochemistry actually deals with mainly two things: conversion of chemical energy into electrical energy or electrical energy to chemical energy. These two are called electrochemical cells. These two processes comes under electrochemical cells. It is of two types. Electrochemical cells is of two types. First type, galvanic cell, also called voltaic cell, or you can tell Daniel type of cell. Daniel, D-A-N-I-E-L, Daniel type cell. Then these are the first category of electrochemical cell: galvanic cell or voltaic cell, or you can tell Daniel type of cell. I will come in details. And second type of cell, that is the electrolytic cell. Then what are their role? These two types of cells are there. What are their role? Then first type, that is the voltaic or galvanic cell. Actually it's a voltaic cell because its unit is volt, or galvanic cell because in the name of scientist Galvani, who have done research. Then this is the first type, and this produces, this cell, voltaic cell or galvanic cell, it produces electrical energy from chemical energy. The device from which, or the device which converts chemical energy into electrical energy, that is called galvanic cell or voltaic cell. And second type, that is the electrolytic cell. What is this? Then electrolytic cell is again a device which converts electrical energy into chemical energy. Means reverse of first one. Electrical energy into chemical energy. Means non-spontaneous reaction now can take place, which reaction which was not by themselves were able to do or react, now they will take part in reaction. Okay, means from the outside you have to apply electrical energy, then it will give you chemical energy, means chemical reaction will take place. The chemical reaction is non-spontaneous reactions which they were not able to take place. Now it will take place. Correct? Then battery is the example. Battery is the example. Galvanic cell and voltaic cell, these you can say, these I told you converts chemical into electrical energy. Then battery is the best example. There you are using chemical energy and you are getting electrical energy. Correct? And for second, what is the example? Then metal deposit. Metal deposit now you are doing by electrolytic cell. Means suppose you have these things, copper you have, correct, or silver you have. Then now if you want to convert, you can say this silver, if you want just to, on silver you want to put a layer of gold on silver, then that is actually deposit, gold deposit, or auric, AU, auric means gold deposit on silver. Then this is done by electrolytic cell. Correct? Then any metal deposition can be done on the other metal by electrolytic cell. Now I will come little details. Okay. First, already I have discussed in the previous classes, I have given a background for electrochemistry. Okay, now I will go details, but I want to brief it now here. In a cell, three important parts are there. First, electrode. Then here electrode is of two types, anode and cathode. Correct? And this third part means first is the electrodes. Electrode means anode, and second is cathode, means two electrodes are required. And third important part is electrolytic solution, suitable electrolytic solution. Many you can say anode may be there, many cathode will be there. Electrolytes will be also different types. Then what is the actually this anode and cathode? Both are called electrodes. Electrodes. And what is the electrode? Then electrode is a metallic strip, metallic rod. This metallic rod can function in both way, as anode as well as cathode, or sometimes same metal can behave as anode and cathode also, but generally some special types are there which can behave as a anode. Metals can behave as a anode and other metals can behave as a cathode. Correct? Then which metal will behave as a anode and which metal will behave as a cathode? This is very, very important things to understand. Many metal rods are there, metal strips are there. Then which will function as anode and which will function as a cathode? That is very, very important. Then here I want to tell you that metal which have natural tendency to dissolve in a suitable solution, as for example Zn in ZnSO4. ZnSO4 is a solution, zinc sulfate. Then when Zn is dissolved in ZnSO4, when metal is dissolved in the, you can say, metal ion, then what will happen? That metal will have natural tendency to dissolve. Then the metal which has a natural tendency to dissolve in the same metal ion, means Zn metal in ZnSO4. Then what will happen? That when it will dissolve, then it will release electron. Means Zn will dissociate like Zn will give Zn ion plus 2 electron. Oxidation. Loss of electron is called oxidation. Then now Zn is converting into Zn ion plus 2 electron. Then this is the process is oxidation. Then this is a one type that here metal is doing. That is a tendency to lose the electron. Here they are losing the electron and converting into Zn ion. Hence with the time all Zn will dissolve and many electrons will be released. Zn rod will dissolve and will convert to the Zn ion. Then Zn ion concentration in solution will increase because it is dissolved in ZnSO4. In ZnSO4, the ZnSO4 it will ionize as a Zn plus SO4 2 minus. Then if metal will dissolve, means as for example Zn, then number of Zn ion will increase in solution with that time, and electron also it will release. Then electron actually it will be on the rod only, on the metal surface. On the metal surface, electron will be on the metal surface and Zn ion will go to the solution. But here you should understand the part which is dissolved, metal part which is dissolved in solution. Then inside the solution some metal parts are there, then electron will be only there on that part only. Metallic rod is dissolved, it is in solution, dipped in the solution. Then Zn is melting and converting into Zn ion plus 2 electron. then Zn ion will be in the solution and electron will be on the surface of metal ion, which is inside, in parts, metal part which is inside of the solution. These important things. Then metal has metal have two type of tendency. One type of tendency that it will lose the electron. One type of tendency. And other metals have tendency to gain the electron. Then that type of metal which has tendency to gain the electron, that is a reduction. Then here they have tendency to take the electron, then that will behave as a cathode. Correct? As for example, copper. When it is dipped in the copper sulfate solution, CuSO4, copper in copper sulfate, then here what will happen, that now copper is dipped in the copper sulfate solution. Then copper will dissolve in solution as a Cu++ plus SO4 2-. Then this copper ion will be on the surface of Cu++ will be on the surface of copper. Cu++ will be on the surface of copper rod. That same things, now it is dissolved in the solution. Then under the solution, which the part of the copper which is under the solution, on that surface copper ion will be there, Cu++. Copper sulfate was there, that copper ion. Then now what will happen, that now suppose if you will join both you can say rod or metal strip, means Zn and copper, via any wire, conducting wire, through voltmeter or ammeter, anything. Then what will happen, that actually this solution, copper sulfate solution and ZnSO4 solution, maybe two conditions are there, maybe in the same compartment. Okay, only in the one compartment you can say both rod will be dipped and both solutions are present, copper sulfate also, Zn sulfate also. This is the one type. Second, that separate you can keep Zn in one compartment. In one you can say these things separately in one beaker, like that you can keep, and other you can keep separate beaker. Correct? Then two type of arrangement there. One, you are allowing to both mix, means only in the same compartment, same utensil, same vessel, both you are keeping. Other type, that separate Zn-SO4 you take, Zn copper sulfate, separate copper sulfate you take, and Zn you in Zn-SO4 Zn rod, in copper sulfate copper rod you put, and both you join through a conducting wire via voltmeter or ammeter. Then you will find that current is flowing from anode, means from Zn, to cathode, means copper. Correct? And how much current is flowing you can measure, or how much voltage flowing, producing, that you can measure it. If a voltmeter if you join a voltmeter, then it will tell volt, how much volt it is producing. Now it becomes cell. Both are called half cell. Anode and cathode, both are, means Zn and Zn-SO4. This is a half cell. copper in copper sulfate, this is called half cell. Then now these two half cell you have joined, then it become full cell. Okay. Then here you have seen from that is the anode Zn, now it behaves as a anode. Cathode, and copper is behaving as a cathode. Then current is flowing, means electron is flowing from Zn rod to copper rod. Electron will flow. Correct? Flow of electron, that is called current, means current is flowing. Then you can, if you want to measure the current, how much current, then ammeter is joined. And if you want to know the voltmeter is joined. Okay, through voltmeter you can say current will flow, or through ammeter also. Then you can pass the current, you can say through wire via voltmeter or ammeter. Then it is a sure shot that current will flow. But here only in the beginning I want to tell you that electrons flow from anode to cathode, means Zn to copper. This is the direction. But what is the direction of current? Electron direction is from anode to cathode. But current direction will be opposite to electron flow. Question is asked. Okay, keep in mind. Then now that you have to understand many things. First things, that why anode is becoming, you can say, negative, and why cathode is becoming positive. You have to understand. Anode is negatively charged, cathode is positively charged. This in case of galvanic cell or voltaic cell or Daniel type of cell. Daniel cell means here when you are using copper and Zn rod. Copper and Zn rod means Zn as a anode, copper as a cathode. Zn is for copper in copper sulfate. Actually first time only this was made. Then this is also galvanic cell. But here in Daniel cell, Zn in Zn copper in copper sulfate will be used. Then it will call Daniel cell. But this is actually example for voltaic cell also, voltaic or galvanic cell. Because now this is the individual case. Because many metal can be used as anode and cathode other than copper and Zn. Then they can make different type of cells. Different type of cells they can make. Then that is called Daniel type of cell. And that Daniel type of cell is called galvanic cell or voltaic cell. Correct? This is very, very important because many metals are there other than copper and Zn. Then that is called, in general it is called galvanic cell or voltaic cell or Daniel type cell. Correct? I am telling now only for galvanic or voltaic cell or Daniel type of cell, not the electrolytic. That will be discussed in the end. Then now question is that why it is a negatively charged, anode is negatively charged, and why cathode is positively charged in case of galvanic cell. Question is asked. Then in the beginning I told you that some metal has some metal rod, whatever you want you can tell, has tendency to lose the electron, and other metals have tendency to gain the electron. Then metal which has more tendency to lose the electron, then what will happen, that this oxidation reaction will take place. As for example, Zn will convert to Zn plus 2 electron. This is the oxidation. Then already I told you Zn ion will go in the solution and concentration of Zn ion will increase. because already ZnSO4 was there. And now after dissolving this metal, then they are now their concentration is Zn ion concentration is increasing. Then Zn is positively charged, electron is negatively charged, and this positive charge will be near the electron. Correct? This. Then here what will happen? This positive charge Zn ion wants to come on the surface of a metal. It wants to come, and there electron is there. Electron is also there. Then here Zn ion also wants to come, positively charged, because electron is there negatively charged. Then they will make a layer, dielectric layer. It will make a two layer. Okay. Negative charge due to the electrons will be there, and positive charge due to the this cation, means metal ion. Then this two layer, dielectrical layer, you can say, di means two, electric means negative and positive. Then they will maintain one equilibrium. Electrolyte which is in the solution. Electrolyte means metal ion in the solution, like Zn++, and negative electrons. There they will maintain one equilibrium, because two type of charges there, negative and positive. Then they will maintain one equilibrium, and due to this two opposite charge, negative and positive, they will create a potential. Due to these two negative charge at equilibrium position, they will create a potential. Potential means power, you can say. P, potential. Potential means power. Then it creates this two different type of charge. They creates potential. Same things happens on copper side, cathode side also. It also there in the beginning positive charge will be there. Copper ion will be there. Copper rod in copper sulfate is there. Cu++. That will be on the surface of copper. An electron will come from the zinc side, from the Zn. Then again same thing will happen, because more copper ion was positive ion, copper Cu++. It was in more quantity. That's why cathode become positive, and anode side, zinc side, electron was more fast. It was just oxidizing fast. Then here electron was there. That's why this anode became negative, because on the surface electron were there, and they have more tendency to lose the electron in comparison to that copper. Then anode became negative because of electron, and only from anode electron goes to the cathode, because on anode electrons were more. Then it was going from Zn to copper side. And on copper, because copper Cu++ was there on the surface, then now this is going, electron is going there. Then there again same thing will happen. Two layer it will form, positive and negative. Okay, dielectrical layer, that is called dielectrical layer. Question is asked. Then now there they will make dielectrical layer. There also equilibrium will be there. They will maintain equilibrium. Then they will also produce potential. there also at cathode also potential will be developed. Then now this on anode also potential developed, cathode also potential developed due to two different charge. Then here more potential on Zn, on anode, more potential develops. Okay, because they have more tendency to lose the electron. Then now at anode potential is also there, cathode also potential is there. Then now both electrode has potential. Then both have different potential, not unequal. Anode side more, cathode side less. Then what is the difference between two potential? That is called electrode potential. That is called electrode potential or cell potential. EMF, electromotive force, EMF. But EMF you will tell only when both side this electrolyte have this electrolytic concentration is 1 mole. Okay, that time temperature is 270, this things 298 degree centigrade, correct? Then means temperature pressure is 1 atmospheric pressure. That time what is actually potential? That is called EMF, standard EMF, electromotive force. Standard means you should temperature, pressure should be fixed. Third things here, molar concentration should be 1 unit. 1 unity. Unity means 1 mole per liter. Both side, cathode side also, anode side also. Both solution, electrolytic solution concentration must be 1 mole per liter. Then it is called standard electrode potential. Then now I told you why anode is negative, why anode is positive. Okay, electrical double layer also I have told you. Now potential also I told you what is the potential. More the tendency of potential, more the tendency for oxidation. For oxidation means it will produce more electron. And process is oxidation. That's why it is called oxidation potential. And cathode side reduction is going on. Then that potential is called reduction potential, because reduction is going on. Then you know that oxidation potential, value of oxidation potential and reduction potential will be equal. Oxidation potential and reduction potential just there they both are equal but in opposite sign. But in cell case is different. What they are producing, that is the different case. But if oxidation potential is given, then just to change the sign, that will be the reduction potential. If negative is there, oxidation potential, suppose it is 1.1 volt minus 1.1 volt. Then what will be reduction potential? Plus 1.1. That's enough. Only sign you have to change it. Or if reduction potential they have given, suppose it is plus 1.5, then reduction potential will be minus 1.5. But in cell what they are producing, that is different case, because that depends upon the tendency to lose the electron. That is called potential. If metal rod is dipped in the solution having the same cation, that is the tendency. When metal rod is dipped in the solution having the same cation, means metal ion, then that type, what is the tendency to lose the electron? That is called potential. Then this tendency may be different type. Some may have more tendency, other may have less tendency. Then metal which have more tendency to lose the electron, that will be treated as anode, and which has a less tendency to lose the electron, that is treated as cathode. Correct? Then you have to compare. If they will give two rods and they will ask you to this which will be anode and cathode, which can behave as anode and cathode, then only by knowing their potential tendency to lose the electron, which one is losing fast, then that will be anode. Which will lose fast, that will be anode, and which will lose slow, that will be cathode. Other metal may be there. Other metals, many metals are there. Then you can't tell. You can only, this is the only basis on which you can decide which metal can function as a anode and cathode. Whose tendency is more to lose the electron, very simple way. That will be treated as anode. And whose tendency is less to dissolve, that is treated as cathode. Okay. In electrochemical series, you might have seen different values are there, is given for potential. They have given different values. But here I am telling you these things. Many things I have to tell, but this basic thing, concept I am telling you, this chapter is full of concept. Without nobody will generally dare to touch this electrochemistry. Physical chemistry itself is a very conceptual, full of concept. Then now here, this electrochemistry, in that now I am telling you cell is the main thing. Then here that Zn ion concentration increases with the time. Then in cathode type, you can say there what will happen in cathode container, that compartment there copper ion is converting into metal. Copper ion, after taking the electron which is coming from the zinc side, from the anode side, that electron they will take. Suppose 2 electron they release and it came here. Then copper Cu2 plus 2 electron, this is called reduction. It will convert to the metal and it will deposit on the copper rod. Then many can say Zn ion will lose the electron, then many electron will come and all electron will be taken by copper ion and it will convert to the metal, copper surface of copper metal. This copper ion will deposit as a copper metal. Then you will find that copper will deposit on the copper rod. Later on you can remove also. Then you got the copper. Then obviously now that in copper sulfate, what you have taken in the beginning, solution, that their concentration is decreasing because copper ion is converting to the copper metal from the solution. That in solution copper ion will decrease. Then here copper ion is decreasing, only sulfate ion is remaining there. And this side, Zn side, means anode side, Zn ion is becoming more. Zn ion is becoming more because already ZnSO4 was there and Zn also came from metal, Zn metal. Then here Zn ion concentration is more. And then I told you flow of electron. Flow of electron is the current. Correct? This is a definition, flow of electron. There are two, you can say two definitions, flow of electron or flow of charge. Both are called current only. But direction of current is opposite, I told you. Then here, because from the copper side, copper now they converted into copper metal. Then what about the sulfate ion? Then sulfate ion will be remaining there. More sulfate ion, less copper ion, because copper ion converted to the copper metal, then more sulfate ion will be there. What will it do? For a single second they can't live without positive charge. Single second also can't live. Then where this sulfate ion will go? Copper ion is not there, positive. Then where it will go? Sulfate ion? Simple ion will be not there. Keep in mind, never any ion will be alone. Always they will be, I can say, in paired. Positive and negative charge will be equal, should be equal. It should be neutralized. Never only positive charge will be there, never negative charge will be there in solution. Never. Then here what will happen? Then this copper ion, this sulfate ion, that will go to this Zn side, where some Zns are without sulfate, because which came from the Zn rod, they are a Zn++ only. They can't live without a negative charge. That's why this sulfate ion will go to there and it will form ZnSO4. Then now in solution ZnSO4 will increase. Concentration of ZnSO4 will increase. Correct? And because sulfate ion went from copper side to Zn side through solution, then how, suppose both containers are separate, then how it will go? They can't jump and go. They can't jump and go. Then how will it go? Then for that purpose, one salt bridge will be there. The meaning of a bridge, you know, in a river, bridge is there. Then from one end you can come to the other end via bridge. The same situation is here, that in the shape of U tube, just like U form, one tube will be there. Then in that tube, some you can say KCl solution or potassium sulfate solution is filled, and there both end is blocked by agar solution. Agar solution means that it will block the both end, but it will allow only for ions. It will allow only to pass ions from one container to the other container. As for example, potassium chloride, saturated potassium chloride, generally it is used in the salt bridge. Okay, generally that type of ion is used which has same type of mobility, almost same, not equal, not 100% equal, almost same type of, you can say, mobility of ions. Then that type of you can say salt is used in the U tube, generally KCl solution. Correct? Then KCl may be dilute, may be saturated, whatever KCl solution is used. Then through this, this bridge will be dipped in both solution, means copper side, from the copper sulfate also, and Zn sulfate also, means both side, cathode side and anode side, it will make contact. Bridge is between ZnSO4 and copper sulfate. It is making a bridge, that is called salt bridge. Then now they can say this transfer of ions can take place. Then that when electron was coming from the Zn from Zn means anode to cathode, that was the direction of flow of electron. But current direction will be from this copper side to, in solution, through solution, from copper sulfate to ZnSO4 sulfate, that side. Okay. Then here I told about the salt bridge also, its purpose also I have told you. Then now this important things I have told you, that what is the EMF, electromotive force, also I have told you. Correct? And why negative, why anode is negative, why cathode is positive, all things. Now you are understanding which metal will behave as a anode, which metal will behave as a cathode, that also I have told you. Then here one more important point I want to tell you, that important things that in cell, so how will you represent the cell? Then how will you write the anode, how will you write the cathode? This is important things. Two things I want to tell you now. First things, anode. Actually, I according to IUPAC, reduction is considered as a standard. Reduction potential is considered as a standard, not the oxidation potential. Reduction according to IUPAC, because they say it converts into the metal, stable. Okay, copper ion is converting into copper metal, means any other metal ion is converting to metal, that is the stable, that is the concentration. Then reduction is considered as a standard potential. Then in electrochemical series, all values are given in the term of reduction potential. Even on a node, whatever potential is there, that is oxidation potential. Then that also you convert into reduction potential by changing the sign. Then it will be easy. Both sides now you will get value in term of reduction potential. Oxidation potential, now you have changed the sign. Then now both sides it will become in term of reduction potential. Then it will be easy to, you can say, differentiate. You can deduct. Then this reduction potential value is given in electrochemical series. Then here, what is the difference? Then right minus left. That is the right hand side. Electrode potential of right hand side minus left hand side. Reduction potential of left hand side, that is that anode side. You have converted, both are now in reduction term. Then RHS, right hand electrode, RHE you can tell, right hand electrode minus left hand electrode. Both are in reduction potential, that is called potential difference. Right hand electrode, reduction potential of right hand electrode minus reduction potential of left hand electrode, that is called potential difference. One important point. And how will you represent the reduction? How will you write the electrode? Then oxidation. You know that oxidation means that is the metal is converting into metal ion. Metal is converting to metal ion, while oxidation, Zn is converting to Zn++. Then that's why it is represented, anode is represented by Zn oblique, single line you can write, oblique Zn++. Zn is converting to Zn++, that is oxidation. This is the way to write the anode. And cathode, that is these things. You will write cation like Cu++ and one line oblique, and Cu means metal ion is converting into metal. Metal ion converting into metal. That's why it is represented like that. One vertical line you have to write Cu++ oblique Cu, or any metal ion. M, in general way you can write Mn+3 as for example, or Mn plus you write only Mn plus a small n. Then that is the ion, metal ion. Oblique means one line you draw, one vertical line, and then only M you write, means converted into metal. And this side, anode side, again you write in a general way, that is the N minus is there, and only M oblique, and then you can write M N plus. M is converting now in Mn plus, means ion. M oblique, one line, and then Mn plus. N is the balance, you don't know, they have lost 1 electron or 2 electron. That's why N small n you are writing. Then M oblique M N plus, that is the representation of a node in general. And cathode, already told you that Mn plus oblique M means you can say that what is the ion you are writing and the what is the going in the end product you can tell. Metal is converting to metal ion, that's why anode you are written, oxidation, and here ion is converting to metal, that's why ion first you are writing, then your metal you are writing. But in anode metal is converting into metal ion, that's why first metal you are writing, then metal ion. This is the representation of anode. And how cell you will represent? Then cell you can represent, first to write anode, after that double line you can write, double line. This also shows double line about the salt bridge. Okay, then anode first to write, again double line you write, that is talking about the separation, and then cathode you write, anode and double line and then cathode, correct. And anode, below the anode you write what is the concentration of electrolyte for ZnSO4. Some concentration may be there, 0.1 m, 0.2 m, whatever we, let's suppose 0.2 was there. Then we write C is equal to, C means concentration, C is equal to concentration, C is equal to 0.2 m. And that side, suppose cathode side, now its concentration may be different, suppose minus 0.1. Then first was C is equal to 0.02. Now here C concentration C is equal to 0.1 m copper sulfate solution or any other solution. Then this is the way to write to express the or to write the cell. And also I told how to write the electrode. Then now we are knowing how to write the electrode and how to represent the cell. Then today now I am stopping only here. Again I will go in details next class. Thank you.